Alright, the deal is, it's called using similar triangles to answer problems. So there's a triangle there, isn't it? Board's gone, is it? Loving my technology. Alright, now you'll notice that that's the first one, alright? And then what we can do is we can do one to here. See the second triangle? Okay, and a very narrow rectangle on top. Alright, and this is basically what we're saying, alright? Okay, that's very fancy, fair enough. Alright, so that's 40, you cool with that? Now, what's the height of the big triangle? You got to take off one, don't you? It would be 9, but you got one taken off it, don't you? So what'll that do? Just 8. Alright, and then the next one down here, 3. Okay, and we want to find out the length of L, do we? Yeah. Alright, well, we know that 8 corresponds to 3, so what does that mean? The big triangle is 8 over 3 times bigger than the small triangle. Therefore 40 needs to be divided by 8 over 3. So what's 40 divided by 8 over 3? So that means the length of L is 15. Is that cool with you? Yes?
We don't have to prove they're similar triangles in any way.
Alright, so 90 degrees, same angle, third angle. Unless I ask you to prove it, you don't have to prove it.
Sir,
You just know they're similar.
how do you know that, with the 1 meter, 1 book?
Yeah.
How do you know that?
Because it wouldn't be a triangle otherwise. So I have to go straight across to make it into a similar triangle question.
Isn't how you can do that anyway?
I know, that's experience.
Okay.
I know I'm using similar triangles, not similar truncated triangles or similar rectangles. I'm using similar triangles. Okay, that's the key. Alright guys, question 8. So Ben looks at a mirror and sees the top of a building. His eyes are 1.2 meters above the ground level as shown. Now what you guys might not be familiar with is that this angle here, this blue angle, is the same as light gets reflected at the same angle. Okay? You're assuming that Ben is standing upright at 90 degrees, as is the building. It's not the Leaning Tower of Pisa. The assumption is that everything is vertically straight up. Is that okay? That will make both these triangles what? And what else? They're similar triangles, okay? Now, first things first. What is 181.5 take away 1.5? 180. What two sides correspond to each other? The 180 and the 1.5. What is 180 divided by 1.5?
120.
Happy 120? What I'm saying to you guys is that this building is 120 times longer than the man. So what that mean about the man's height? The building's height, I mean.
1 point, yeah.
Multiply by 120 and you get?
144.
Is that alright with you guys?
Yeah.
Shh. Which of the measurements was the most difficult to obtain in your opinion? Yes?
Probably like how far away you are from the building. Because 190 is pretty far.
Yeah, how far you're away from the building. Lads, Connor, we all agreed that measuring the distance to the building is probably the hard one.
Yeah.
Okay, you need one of those trundle wheels, wouldn't you?
Yeah, and also because like if you're 100 meters, 180 meters, that's probably like a road or something.
Yeah, I think sometimes there's laser stuff as well that can measure distances. But anyways, we did 6 and 8, and for your homework tonight, lads, you'll see that I've done 1, 3, 5, 7, 9, 10 and 11. Takes 29 minutes according to me. That's your homework.
Wait, so
1, 3,
3, 5,
That.